This video, and really this series of videos, represents a review for the final exam of first semester geometry. So throughout this series of videos, we're just going to do a wide variety of problems, all mixed in together, transformations, similarity, right triangle trigonometry, geometric relationships, proofs, congruence, all of that stuff will be mixed in. Okay, so that makes it really hard to make one nice little video that's about a certain topic because it's all going to be mixed together. All right, so here we go. Problem number 1. Graph the image of triangle ABC after a dilation from the origin by a scale factor of 3/2. Write the coordinates of the pre-image and the image. No work needs to be shown. Okay, well, let's start by writing the original coordinates. So we have point A, which is -1, 5. We have point B, which is 2, 5. And we have point C, which is 4, -2. So if we want to find the image after a dilation from the origin by a scale factor of 3/2, well, when you do a dilation from the origin, all you have to do is multiply each coordinate by the scale factor. So the image, A prime, is just going to be the scale factor of 3/2 times -1, and the scale factor of 3/2 times 5. Okay, that is how you're going to get A prime. Okay, so if I do, well, obviously 3/2 times -1 is just going to be -3/2, which is the same thing as -1.5. So this is basically -1.5. Okay, and in the same way, 3/2 times 5 is 15/2, which is 7.5. All right, and we're just going to do the same thing for B and C. So following the exact same procedure, I wind up with these coordinates for B prime and C prime. So now it's just time to do the graph. Okay, I'm going to change to a heavier ink. So A prime, so I have -1.5, 7.5. So here's -1.5, and here is 7.5. All right, so this will be the point A prime. Okay, B prime is 3, 7.5. All right, so 3, 7.5 will be right here, and that is B prime. And then 6, -3. 6, -3 is going to be right here. And that is C prime. So now we'll just connect the dots. All right, so here is what the image looks like. For the next couple problems, we need to find the scale factor of the dilation. So it's important to just pick a pair of corresponding points and compare them. So I'm going to choose point R because that's the simplest. So we start off with point R, which is 0, 1. And then we end up with point R prime, which is, wait, you know what? That's actually the prime. Let me redo that. Okay, let me see. Okay, we start off with point R, which is 0, 3. All right, so point R is 0, 3. And then we end up with R prime, which is 0, 1. Now, when we find the scale factor, which I represent by the letter K, we always have to do new over old. That's how you find the scale factor. So the prime tells you which one is new. So R prime represents the new point, and therefore R is the old point. So normally I could pick either the x's or the y's, but since the x's are 0, you can't divide by 0. So instead I will just look only at the y's. And so my scale factor is going to be new over old. So that's going to be 1 over 3. Okay, now if this needed reducing, I would reduce it, but 1 over 3 is already simplified. We'll do the same thing with problem number 3 here. So this time I'm going to look at point T and point T prime. So point T is the point 4, 2, and that becomes T prime, which is the point 6, 3. And this is the new, and this is the old. So the scale factor is going to be new over old. So it shouldn't matter whether I pick the x's or the y's. If I pick the x's, it would be 6 over 4. If I pick the y's, it would be 3 over 2. I like the y's just because the numbers are smaller. All right, I've got 3 over 2. So that gives me a scale factor of 3 over 2. So that is the answer. That is the scale factor. Now, just for fun, let's look at what would happen if I picked the x's instead. Okay, so the x's, that's the 6 and the 4. So if I pick that instead, that would give me a scale factor of 6 over 4. But 6 over 4 reduces down to 3 over 2. So you see it's really the same thing. All right, for the next problem we need to find the length marked with a question mark. Okay, so for number 4, I see my question mark right there. I'm going to go ahead and call it X though, sort of instead of a question mark. So it's time to decide what I'm going to do. Okay, I have a choice. I can either use the Side-Splitter Theorem, where I would need an expression for these missing pieces, or I can do old over new. I can look at the triangles separately. I think I'm going to do the Side-Splitter Theorem this time, since we're not dealing with the parallel sides. So first I need the length of GR, which is, it's always the big minus the part. The whole minus the part will give you the other part. So in this case, that's just 169 minus 78. That's 91. So that tells me that this side right here is 91. Now I need an expression for SF. Again, the missing blank, all right, like if I put a missing blank right here, it's always going to be the whole minus the part. All right, so that blank, in this case, that's going to be 104 minus the part that we're given, we're calling it x. So it's 104 minus x. It's always the whole minus the part. So I'm just going to squeeze that in right here. So this is 104 minus x. So now that I have all four segments, or at least an expression for all four segments, I can do the side-splitter theorem. All right, now the side-splitter theorem works like this. I can take these two numbers from this side of the triangle, make a fraction out of them, and I can take these two numbers and make a fraction out of them. Okay, so it's going to be, for example, I can do 104 minus x. All right, I'm doing this over this. So 104 minus x over x is equal to, and then I would have to do 78 over 91. Okay, then it's just a matter of cross multiplying. I don't think this even reduces. So I'm just going to go ahead and cross multiply, even though these numbers are very large. So I'm doing 91 times 104 minus x. All right, that's multiplying on this diagonal, is equal to 78x. So now I need to do the distributive property. So 91 times 104. 9,464. Minus 91x is equal to 78x. I need to get these x's together, so I'm going to add 91x to both sides. So that leaves me with 9,464 equals 169. X 7891. Okay, so now I need to divide both sides by 169. So I need to take 9,464 and divide by 169. 56. I'm really surprised that came out so evenly. So I found that x is equal to 59. Okay, so we are supposed to find the value of this question mark, which I'm going to rename as x, if I may. Okay, and we have the hint. Pay attention to the order of the letters. We need to know which sides are corresponding. So let's see. X is the length of LB. So here's LB, and that corresponds to CB. So LB corresponds to CB. Similarly, KB corresponds to DB. So KB corresponds with DB. Okay, so when I make my proportion, like new over old equals new over old, I need to put my corresponding sides in the same fraction. So for example, if I think of this as new and this as old, then it will be x over 14. And then new over old with the squares would be 7 over 18. If you cross multiply, you get 18x is equal to, well, whatever 14 times 7 is. 98. And then got to divide by 18. That's a decimal that goes on forever, so that's no good. So I toggled it, and I will write it as 49/9. Let's do the same thing for number 7. Again, if you don't mind, I'm going to call this X instead of question mark. Okay, so let's see. That X, that's LB. So here's LB, so that's going to correspond with DB. So here's LB and here's DB. And then I've got KB. So here's KB. KB corresponds to CB. So KB and CB. So when I do my proportion, I need to do circle over circle is equal to square over square. So that's X over 18 is equal to 7 over 14. 7 over 14 reduces down to 1/2. So I've got X over 18 is equal to 1/2. If I cross multiply, I will get 2x is equal to 18. And then if I divide by 2, I get x is 9. For number 8, our goal is to prove the triangles are congruent. All right, proving the triangles are congruent. There are 5 ways to prove that triangles are congruent. Depending on the information, if we had 3 pairs of congruent sides, or if we had 2 pairs of congruent sides with the included angle, all right, or if we had 1 pair of congruent sides and 2 pairs of congruent angles, that would work. Or if we had 2 angles and the included side, or if we had a hypotenuse and a leg. So watch out for these. So on this first one, we are given FD is congruent to BC. So let's mark those. So those FD and BC. ED is congruent to AC. So ED is congruent to AC. And finally, angle F is congruent to angle B. All right, so angle F is congruent to angle B. Okay, so what I have is 2 sides and the non-included angle. So if this angle, instead of being F and B, which are not between the sides, if it had been D and C, then it would be side, angle, side. 2 sides with the angle in the middle. When the angle is not between the 2 sides, that would be like as if there was a side-side angle. Whoops. That would be as if there was a side-side angle. But there is no side-side angle. All right? Other than hypotenuse legs, the special case. And this is not a right triangle, so we can't use hypotenuse leg. And side-side angle does not prove that triangles are congruent. So we have to say, what they tell us, we cannot prove that they are congruent. All right, which I guess we can just circle this. And if we're circling this, we cannot fill in the other 2 lines. All right, don't make a congruence statement if you can't prove they are congruent. Okay, okay. FD is congruent to BC. FD, BC. ED is congruent to AC. ED, AC. Angle F and B are right angles. Interesting. All right, so now we know that this is a right angle. So this is the same setup as the previous problem. The only thing is, now we know that these are right angles. Now, because these are right angles, we have the option of using hypotenuse leg if it applies. And guess what it does? All right, HL, hypotenuse leg. See the double tick marks? These are the hypotenuses of the triangles, so that gives us the H. FD and BC, those are legs. So we have hypotenuse leg, and that will prove it. Now, we need to make the the congruence statement. So angle A corresponds with angle E. Okay, angle B corresponds with angle F. And angle C corresponds with angle D. Now on this one, we are given that angle B is congruent to angle D. So there's angle B being all congruent to angle D. And A is the midpoint of BD. So if A is the midpoint, then that means BA and AD are congruent. In addition to what's given, when we see vertical angles like these, we can always mark them congruent, because vertical angles are always congruent. So I see two angles and the included side, two angles and the side that's in the middle. So that is one of the ways. Okay, angle, side, angle. Okay, now triangle ABC is congruent to triangle. Well, A corresponds to A. All right, B corresponds to D. You can tell from the single mark. Okay, so AD, so that just leaves E. All right, this will be the last one on this video. We're given angle B is congruent to angle D. A is the midpoint of CE. All right, that makes CA and EA congruent. And then again, we have the vertical angles that we can always mark. All right, so I have two angles and a side that is not included. All right, so I have two angles and a side that's off to the side. So guess what? That is angle, angle, side. All right, so how do they correspond? Angle A corresponds to angle A. Angle B corresponds to angle D. And that just leaves angle E. All right, there's a lot more to come in the next couple videos. All right, so if you're looking for more review, more final exam review, find the next video in the series. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.